Assalamu alaikum wa rahmatullah. We are discussing regarding the atomic structure. Previously, we have discussed regarding atom, subatomic particles, and different charges from subatomic particles, atomic mass unit, atomic number, electronegativity and electropositivity of atoms, ionization energy, electron affinity, Pauli exclusion principle, Nernst rule, and so many things. We were discussing regarding different mass of an atom. When a particular atom exists in different mass, then this atom, particularly this atom, is said to have isotopes. For example, chlorine exists with atomic mass 35 and also atomic mass 37. This is happening because of the different number of isotopes. In chlorine 35, there are 17 plus 8, 17 protons and 18 neutrons. Its atomic mass is 35. In chlorine 37, its atomic number is 17, number of protons is 17, and number of neutron is 20, so its atomic mass is 37. Similarly, in hydrogen, there are 3 isotopes. One is protium, then is deuterium, then is tritium. In protium, there is no neutron. There is only one proton, and its atomic mass unit is 1. In deuterium, there is 1 proton, 1 neutron, its atomic mass is 2. In tritium, there is 1 proton and 2 neutrons, so its number is 3. The number of proton is same in every case, but the number of neutrons are differing from 1 to 2, 3, and thus their atomic mass is changed. Helium exists in 2 isotopic forms. Lithium exists in 2 isotopic forms. In this case, you will see that there are 3 protons and 3 neutrons, and here there are 3 protons and 4 neutrons. In helium, there are 2 protons, 1 neutron, and here 2 protons, 2 neutrons. It's 4. So, which mass will be taken for atomic mass of the atom which exists in different isotopic forms? For example, oxygen also existing in 2 isotopic forms. So the atomic mass, the atom with 8 proton and 8 neutron, that is atomic mass neutron, it is abundantly available. So this atomic mass 16 is usually attached to the chlorine, to oxygen. Similarly, in case of your carbon 12, carbon 13, there are 2 isotopes. In carbon 12, there are 6 protons and 6 neutrons, so its atomic mass is 12. In case of carbon 13, its proton number of protons is 6 and the neutron is 7, so its atomic number is 13. This is not abundant in the nature, only C12 is abundant in the nature. So the most abundant its atomic mass is usually, and the actual atomic mass is taken from the average of their masses of isotopes that is obtained in the nature. Calcium, its atomic number is 20 and its atomic mass is 40. So number of protons 20, number of neutrons 20 here, and the electrons 20 electrons is arranged as in first cell 2 electrons, second cell 8 electrons, third cell 8 electrons. And in 4s there are 2 electrons. Valence cell electrons, that is the outermost electron cell, valence cell. So there are 2 there. For calcium there are 2 valence electrons, and its valence is 2. So this is the summary of the atomic structure that we have discussed. Atomic number is the number of protons in the nucleus. Atomic mass, atomic number of protons and number of neutrons in the nucleus. Number of protons is equal to number of electrons in neutral atoms. Electrons orbit in the nucleus cells, and each cell can only carry a set number of electrons. Atoms sometimes become positively charged, which are electropositive atoms. They take ionization energy and leave the valence electron. Thus, sodium, whose atomic number is 11, it leaves one electron and becomes positively charged. And when it becomes positively charged, then it loses one electron. So its number of electrons in sodium positive becomes 10. In chlorine, there are 35 protons. There are 17 protons, and it can take another electron to become chloride ion. In neutral atom, there are 17 electrons, 17 protons, and so there should be 20 number of neutrons. When sodium is positively charged, then it loses one electron, and it becomes its number of electron is there 10, and it takes the shape of the nearest noble gas structure neon. Similarly, a nuclide is noted with its for example, oxygen. In case of oxygen, its atomic number is 8. So number of proton is 8. Yeah, and its number of neutrons in oxygen 16 is also 8. When it releases 2 electrons, when it gains 2 electrons, it becomes doubly negatively charged. Then its atomic number becomes 10, and it takes the shape of the nearest noble gas neon. Rutherford proposed the structure for an atom as and at the nucleus of the atom, massive positively charge is there. This charge is different for different atoms. Nucleus is only a minor fraction of the total of an atom. It has lot of empty space, and electrons are revolving in closed orbits in a plane. The Rutherford's model was untenable because of the theory of electrodynamics doesn't support that theory of electrodynamics doesn't support that a charge particle rotate around again the charged nucleus. If it rotates, then its energy will dissipate, and ultimately it will coincide with the nucleus. So atomic structures of the idea of atomic structure that was proposed by Rutherford that died. That is untenable. It is not existing. Bohr, the student of Rutherford, and he proposed that electrons are moving around the nucleus, and he explained the emission spectra and absorption spectra of hydrogen atom, and explained the spectra that series, Palmer series, Besson series, Home series, Brackett series. So he also supported the idea that orbital circular, and electrons are moving in this circular orbital around the nucleus, which is massively positively charged. And he added that this electron may absorb energy, jump from one level to the another level. If delta E energy is absorbed, which is E2 minus E1, then will take this, it will be excited, and with this energy, it will go to the upper level. And if it releases this energy, then it is coming down from E2 to E1. An electron can move in orbit when its angular momentum r is equal to n is twice pi. And when it comes, relationship is not maintained, then it comes down to another orbit where this relation again exists. So energy is quantized. Limitation of Bohr model: it cannot be generalized for all systems. Only it is applicable for hydrogen one electron system. It cannot explain closely spaced lines. It cannot explain the rate of, cannot calculate the rate of transition. The Bohr model was eventually suspended by quantum mechanics proposed by Brogley, Schrodinger, and Heisenberg. Actually, they proposed that these atoms are not two-dimensional, but they are three-dimensional, and they gave different quantum numbers for electron to describe its energy level, its alignment, its position, etc. The energy level is defined by its principal quantum number n, and the shape of the orbital is defined by its azimuthal quantum number or subsidiary quantum number L, and then the magnetic quantum number defines its position in the space in a three-dimensional case. And later on, Einstein, from his theory of relativity, showed that that the electron where two electron lies in a single orbital, then they must have different different spin, and if one is given plus up spin, that is positive spin, then another electron will have a negative up, minus up spin, and thus the 4 quantum numbers were assigned to a particular electron. Pauli Spaceful showed that no two electrons in an atom can have all the 4 quantum numbers identical. See, the principal quantum number, it may have number 1, 2, 3, up to infinity. And azimuthal quantum number L have value at least 1 less than this principal quantum number. So if n is 0, then n is 1, then L is equal to 0. If n is equal to 2, then L is 0 and 1, etc. For principal quantum number azimuthal quantum number may have n minus 1, n minus 1 have value up to n minus 1 from 0 to n minus 1. And for each value of L, that is azimuthal quantum number, the electron may have twice L plus 1 from minus L to plus L, twice L plus 1 number of magnetic quantum number. Thus, if n is equal to 3, then L may be 0, 1, and 2, and for each of 0, 1, and 2, its magnetic quantum number or its which specifies the orientation of the orbital in this space should be minus minus 1, 0, then plus 1. That is twice 1 plus 1, that is 3, which are given digital port as Px, Py, and Pz. Thus, we can assign 4 quantum numbers to a particular electron. We have discussed Pauli exclusion principle, also Hunt's rule. In Hunt's rule, it says that in orbitals of same energy state, a maximum number of unpaired electrons may exist. Say, for example, in P level, there are 3 equal energy levels, that is equal energy 3 orbitals. So maximum 3 unpaired electrons may exist there. In D level, there are 5 orbitals. So maximum 5 number of electrons may exist there unpaired. In F level, maximum 7 number of electrons may exist in unpaired form. This was proposed by Hunt's, and according to this name is known as Hunt's rule. The electrons in outermost shell are the most energetic valence shell electron, and they play a role in chemical bonding. Elements with similar properties generally have similar outer shell configuration. Alkyl metals form positive ions, isoelectronic with the nearest movable gas, and non-metals form negative ions, isoelectronic with the nearest movable gas. These are the configuration of electronic configuration of lithium, sodium, potassium. Since after gaining energy, when it lithium loses one electron, sodium one electron, potassium one electron, then it becomes a unipositively charged, and then lithium takes the electronic configuration of helium, sodium takes the electronic configuration of neon, and potassium takes the electronic configuration of argon. Similarly, these are the electron configuration of barium and barium 2 plus, magnesium, magnesium 2 plus, aluminum and aluminum 3 plus. You see the principal quantum number 1, 2, 3, 4, and corresponding azimuthal quantum numbers, corresponding magnetic quantum numbers, and number of electrons that it may contain. The electrons are filled in according to a scheme known as Aufbau principle, and this is like this. And it is need to memorize this thing. You can have the idea that 1s, then 2s, 2p, then 3s, 3d, then 4s, 4d, 4f, then 5s, 5p, f, then 6s, 6p, 6d, 7s, 7p. So you go in this way, and 2s, 2p, 3s, then after 3D, is going to 4B, then 5B, then 4B, then 5B, then 4B. In this way, to avoid principle, you can take decision or orient the electronic configuration of the different atoms. So this is shown in the periodic table chart. There one is, but one electron is there. 1 is 2 in helium, 2 is 1 in lithium, then 2 is then there are 2 s electrons and 6 p electrons. These s these are known elements in this region are known as s block elements. Elements in this region they are known p block elements. Elements in this block region they are known as d block elements. And the elements in this region are known as rare earths. The first series is known as actinides, and the second series is known as lanthanides. This is known as lanthanides, and the second series is known as actinides. In quantum model, electron cannot be found precisely, but there is a probability of finding an electron, and thus mathematically the shape of the electron orbit is assigned. The principal quantum number is an integer, maybe 1 to infinity, since the electron. The principal quantum number in integer 1 to 3 describes the electron cell, the energy level in the each cell. The value of azimuthal quantum number is always 1 less than the principal quantum number for if n is equal to 1, then L is 0. If n is equal to 3, then L must be one less. So the value of L are more commonly called for 0 S, for 1 P, for 2 D, for 3 F. 0 is S, 1 is B, 2 is B, 3 is F in this way. In S level, it can accommodate maximum 2 electrons. P level can accommodate 6 electrons. D level can accommodate. You are acquainted with the spectra, Riemann series, Balmer series, Paschen series, bracket series, Fourier series. Only the Riemann series spectra is taking place in ultraviolet region, and Balmer series taking place in visible region. Other spectrum are taking place in infrared region. And Riemann series, in Riemann series spectra, the electrons are coming down from second, third, fourth energy level to the first energy level. That is ground state. And brackets is 4, 5, 6. So these are different spectral region, and they are taking place in different region of electromagnetic radiation. And from in case of Riemann series, it is coming down to ground state from 2, 3, 4, 5, etc. state. It is coming down to second state in Balmer series from the upper other. In case of the Paschen series, it is coming down to the third level from its upper fourth. This is showing the Riemann series, Balmer series, and Paschen series. These quantum numbers is there. Principal quantum number 1, 2, 3, 4. These are also denoted by K. And azimuthal quantum number 0 is S, 1 is P, 1 is P, 2 is D, S, the atoms in the different level, say first energy level, second energy level, third energy level, are having their electronic arrangement, and is shown here for second atoms in the second energy level. That is, principal quantum number is 2. May have L0. Principal quantum number 2 may have L1 for the 6 electrons, and magnetic quantum number like this. And in each case of magnetic quantum number, it may have plus or minus up. So In second level, the total number of 8 electrons. These electrons for first electron, this second electron, this third electron, this fourth electron, this fifth electron, this sixth electron, this seventh electron, this. These are the electronic arrangement, that is the quantum number, their ID number of the electrons. So no two electrons are having same 4 quantum numbers. For example, these 2 electrons are having same 3 quantum numbers, but the fourth is different. These 2 electrons have same these 3 numbers, but the fourth one is different. These 2 electrons have the same these 3, but these 2 are different. So this is showing the Pauli exclusion principle. Now, regarding the periodic table of elements, periodic table lists the chemical elements in increasing atomic number. The periodic table arranges elements with similar chemical properties in groups. That is the vertical column. All elements in a group have similar chemical properties as they have same number of outermost electrons. Periodic table shows metals, non-metals, metalloids, transition metals, then alkali metals, alkaline earth metals, which are most alkali metals and alkaline earth metals are reactive metals. Similarly, halogens amongst the non-metals are most reactive. Noble gases, they are totally unreactive. The first 2 groups, that is S block, and the last 6 groups, P block, together constitute main group elements. These are known as representative elements. D block elements are known as transition metals, and F block elements are known as inner transitions. The inner transition metals are again of designated first 14 elements as lanthanides, and this second 14 elements as actinides. Metallic character is the tendency of an atom to lose electron, gaining energy, that is its ionization energy. Alkali metals are the most electropositive elements. It is also known as this is the phenomena known as electropositivity. The tendency of an element to accept electrons to form anions is called its non-metallic character or electronegative character. Chlorine, oxygen, phosphorus, they are electronegative, and through their non-material character, they accept electrons. The amount of energy that requires to lose on electron from outermost cell of an atom in its gaseous state, it is its ionization energy, and the electron affinity which is released to remove or to gain one electron from gain an electron in its outermost cell and become stabilized is known as its electron affinity. Regarding the nature of bond, when 2 atoms of similar electronegativity are attached together, say 2 oxygens are attached together by sharing their 2 and 2, 4 electrons, forming a double bond. So this is an example of a covalent bond, and this is non-polar. Similarly, if 2 hydrogen atoms or 2 chlorine atoms are connected together, they construct and becomes stable, and they are non-polar bond. But in case of hydrogen chloride, hydrogen being less electronegative than chlorine, becomes partially negative charge and hydrogen becomes partially positive charge. So this molecule is a polar polar molecule, and the bond between this is a polar bond. In case of your potassium iodide, potassium loses this electron and becomes positively charged, and iodine gains the electron and they become a negative charge. So attraction between potassium and iodine is electrostatic attraction. This is known as their electrovalency or ionic bond. So we are acquainted with ionic bond, covalent bond, then polar bond, non-polar bond. Then there are some bonding, coordinate bonding, where one pair of electron is donated by a group that is known as ligand group, and that is accepted by another metal or some other elements. Thus, a strong binding is created between those two atoms or group of atoms. And this type of bonding is known as your coordinate bonding. In metallic bond, the metal loses one electron and it shares with the electron of other metal atoms. So all the metal atoms, after leaving their electron, a common electron cell, electron cloud, electron sea is generated, and all are bounded by the cluster of electrons, which are labile electrons, and thus metals become conductor, good conductor due to this levelity of these electrons. There are some other bondings like your hydrogen bond, then van der Waals forces, etc. So these are the things which were to be discussed with you regarding atomic structure. With thanks, I hope that you will do better in your information now. Assalamu alaikum.